Okay, we're going to go ahead and get started. Today we're going to be covering the Guide to Networking Essentials text in CTI-120. It's the 8th edition of the text. And we will be covering Chapter 12, Network Management and Administration. In this chapter, we're going to introduce you to creating and working with user and group accounts. You will also learn how to manage permissions for users and groups and how to work with shared files and printers. You will also discover how to monitor a system's performance and reliability. And then at the end of the chapter, we'll learn about the importance of fault tolerance and backup. So that's our objectives for this lesson. So when we're administering a network operating system or server, we're going to have to create user accounts. And user accounts have two main functions. It provides a method for users to authenticate themselves using username and password or a smart card. Users allow us to set up authentication on our system so that users can prove who they are. We also use users to record detailed information about a user. So a lot of businesses now, since Active Directory is based on is a directory that keeps information, they use it more like a phone book in addition to authenticating users. So in my account inside of Active Directory, I'm going to keep track of everything. I'm going to keep track of the user's home address. I'm going to keep track of their office number. I'm going to keep track of their shoe size and their uniform size. All of that information is going to be kept in Active Directory. So when we think about these user accounts, we typically think about service to the end user to authenticate them to the system, but it also provides HR resources so that we can record information about users. We also have groups, and groups are used to organize users so that it eases your administration. So when a new user comes in, instead of going through the server and trying to figure out what they should have access to, I'm going to have pre-made groups for different departments. So if somebody comes on board and they're in a marketing department, all I have to do is throw them in a marketing group, and then they're going to have all the permissions to the files and resources that a person that works in marketing is going to have. So it's a lot easier for me to do that, and I make less mistakes if I use groups instead of assigning permissions directly to users. The only location that a user should have direct permissions assigned to the actual user is going to be in their home directory. Every place else on the server, we're going to use group permissions. When you create one of these systems and you have more than just you working in the IT department, you're going to have to start using conventions or policies for creating accounts. These are some of the questions you need to ask and maybe have in your policy. And what you want is uniformity so that when I look at account's name, I can tell exactly who that account belongs to. And also, if we're going to integrate it with our email system, we want it to be something predictable that people can easily email each other. For instance, if it's their first initial or last name for the entire company, it's easy for me to figure out what someone's email is going to be. Some other things you need to look at is there a minimum and maximum number of characters in the account names. That's going to be important because if you make it too short, then we're going to have a lot of duplicates, a lot of collisions between people's names, and we're going to have to start adding numbers behind their names and things of that sort. It makes it more difficult to figure out who the account belongs to. And then there's some systems where your user account name can only be so long because the system doesn't support a longer name. So we need to take that into account too if we're using single sign-on. We also should decide whether it should be based on a user's real name or should be something cryptic like a number. Like I said, if we're going to be using it for email, we probably want to base it on the user's real name. If we're really worried about security and people figuring out whose accounts are whose, we might just want to use random numbers. Some operating systems, such as Linux, distinguish between uppercase and lowercase letters. So should the usernames be all lowercase, or should it be all uppercase, or should it be mixed? These are decisions you need to make, and it's going to impact your support later on. And users having to remember to capitalize the first letter of their username is going to be frustrating. So it's important that you put this policy in place and that all your IT support people follow it so that we have uniformity. We also need to set policies for their passwords, a minimum length. Minimum length means that I'm going to say you need to have at least 7 characters in your password. Why would you do that? Well, if the password's too short, it's really easy to break. We need to have passwords at least 7 characters, or it would be too easy for a computer to brute force the password. Complexity requirements means that I'm going to have to use different types of characters on a keyboard. Uppercase, lowercase, numbers, and symbols are the 4 different groups of types of characters that you can put in a password. So if I just have lowercase letters in my password, then they only have to try the letters A through Z lowercase. If I have uppercase and lowercase required in my password, then they're going to double that. They're going to have to try 52 different characters. So the more types of characters you put in the password, the longer it takes for somebody to brute force the password to break into it. We need to decide whether the user can set their own password or the administrator has to set the password. If an administrator sets the password, the user can't use it, can't choose their own password. Chances are that person's going to write down their password somewhere because they can't remember it. Most places allow the users to pick their own passwords. Right? It's just easier for them to remember, and it's less chance of them writing it down someplace. We also need to decide how often we need to have passwords change. I know it's aggravating for end users to have your password change every 45 days, but there's a couple of reasons we do that. One of them is for brute force attacks. Brute force attacks against passwords, where you try every combination of every letter, work 100% of the time if given enough time. So eventually they're going to get your password with a brute force attack. If we change it every 45 days, the attacker needs to restart their guessing every 45 days. The other reason we want to change our password frequently is if they have access to my account and I do not know it, then that limits the amount of time that they have access to my account. Because typically once they figure out your password, they don't change it. If they change it, then you're going to know somebody's using your account. If they just leave the password the way it is, they can continue using your account and you have no idea they're using your account. So changing it every 45 days limits how long they have access to your account once they figure out your password. So those are some reasons why we need to make these policies. These policies probably need to be made by the business people in your organization, not by IT people. Group account name should reflect the group membership. So the group account should be something that makes sense. Like if a group is for marketing employees, you probably should call it marketing. Remember to stick with the naming conventions once you start them, because if you keep changing them, you're going to have problems figuring out what's going on in your network. One thing you need to remember is that there are some system created accounts. So When you first install Windows, there are two accounts that are created. One is called Administrator and one is called Guest. Those two pre-made accounts, those special accounts, cannot be deleted. On the Windows Server 2019 domain controller, which is going to be the version if you install a new server, the guest account is going to be disabled by default. You're going to set a password for the administrator account, but the guest is going to be disabled. In Windows 10, the workstation version, both administrator and guest are disabled. You create a user when you first set up the computer that's going to have administrator privileges. Know that administrator account has privileges to everything on the system. It's the account that is the most powerful on the system. And the guest account is an account that has the least amount of privileges and is used for guest access to the system. Most of the time, you don't want to use either one of those accounts. The reason you do not want to use administrator account is because then if you share administrator account with multiple people, then there's no accountability. So, for instance, if I give the administrator account to 3 system administrators in the IT department, then if somebody does something on a server, moves some money turns up missing, something of that nature, you're not going to be able to tell who did it because all 3 people are using an administrator account. So what you need to do is set up an administrator account, set a really long, strong password on the system, and then put that password away someplace. That's going to be your backdoor access in case your system administrator gets run over by a bus or something. You need to get back into the system. You don't want to have to break in. So administrator account password should be set to something like 30 characters, really strong, and then the password should be stored someplace where you can tell if somebody has tampered with it or gotten to it. The guest account should be disabled. Those 2 accounts cannot be deleted, but they can be renamed. So you can change the administrator account to something else, like power user or something like that. Remember, the administrator account has full access to the computer. In a Windows domain, in a server environment, the administrator account's access is extended to all computers. So the administrator account inside of on the server has full access to all the computers on the network. So we really need to protect those accounts. So make sure that when you set up a new server, you take care of that when you first start it. If you don't, people could be trying to get into your system. So when you're in a domain or in a server environment, you're going to create the accounts in Active Directory users and computers control panel. So it's a different place than if we create them on a computer. We have a special program or a snap-in called Active Directory users and computers, and you're going to use that to create your users. When you create users on a domain or in a server environment, those users typically have access to all the computers in the company. So I create one user on one computer on the server in Active Directory, and then that user can access all of the computers in the organization. I don't have to run around to every computer and create an account for them. Likewise, if they change their password is changed in Active Directory, password changes in all the computers. If you start making accounts on local machines instead of on the server, then that person might change their password on one computer and the passwords would be out of sync on the different computers. So if you have more than 10 computers, it's best to have this domain or server environment. We can also create folders for organizing users called organizational units. I use those to keep track of my users and know what department they're in. I'm also using them to apply settings to those users. This is with the Active Directory users and computers. dialog looks like. Let me get my mouse working. Give me a second. Pull up my laser pointer. Okay, so once you do Active Directory users and computers, you can see we have all of our users there and our groups, and then we also have these folders in Active Directory users and computers, and those are called organizational units. Notice we have one called built-in, we have one called computers, one called users. Those are going to be the groups that we use to organize our users, and they're called OUs, or organizational units. This is what the new user dialog box looks like. We create a new user, we're going to have to use their first name and their last name, and then assign them a login name. The logon name, remember, is going to be based on our policy that we created. When we create the user, it's also going to ask us for password. So we're going to set an initial password on the user. We always want to check the box that says user must change password at next logon. That forces the user to change the password when they log on to the system. The reason we do that is we don't want to know the user's password. If we don't force a password change, then the user can always come back and say, administrator knew my password. He could have done whatever the person's being accused of. He could have stolen the money, not me, because he knew my password. When we force them to change their password, that makes sure that we don't know what their password is. Here's where we keep all of the information about the user. Remember, I said this is a database for HR information also. So there's the office, the telephone number, email address. When you create a group account in Windows, they require a name to create the group. Remember, the group should be named something that makes sense. If the group is being used to assign permissions and access to people in the accounting department, you probably want to name the group marketing, right? Or whatever department that you're creating it for. After you create the group, you can start adding users to the group. There's 3 different options that you can create. One type of group is called domain local. It can only be used to assign permission to items in the same domain. You can have a global group. You can assign permission from the domain in which they're created, but can be assigned permissions or resources in other domains. So these different types of groups are different in that who can be members of the group. So in a domain local group, the users that are in the group can be from any domain, but you can only assign permissions to resources in the same domain. With a global group, you can add users to the group from the same domain, but you can assign them permissions to resources or objects in other domains. So it all has to do with where the users are coming from and where the resources are that you're giving access to. You don't have to understand the difference between those. When you get into NOS 230 or some class like that, you'll have to know, but just know that there's 3 different types of groups. And then we also have different group types. So we have group scopes, which would be the domain local, the global, and universal. And then we have group types. The group type is security and distribution. Security can be used to assign permissions in the file system. Distribution is used for email. I can assign permissions to a distribution group. I can't assign resources to a distribution group. It's only used for email. And you say, well, Joe, why would I create a distribution group if I can't assign permissions to it? A distribution group can contain users from other companies or email addresses from other companies that don't have access to your system. So just remember, security groups or you can send email to them, and you can assign permissions to a security group. However, you can't put people that are in other companies into a security group. Distribution group, you can have emails from other companies, and it's an email list, but you cannot assign permissions to it. Here's a dialog box that shows you creating a new group. Notice we're going to have to pick the scope and the type. We have some default groups that come inside of Windows. They have pre-assigned permissions that apply to all of the group members. And then we have special identity groups. Default groups are built by the system, and it makes your job easier because you have groups that have the correct permissions. An example would be remote desktop users. So if you wanted users to be able to connect to their computer from home or over the internet, you can use the remote desktop users group. That's an example of a default group. Special identity groups are not really groups that you can modify. Special identity groups, the membership of those groups are controlled by the operating system. An example would be authenticated users. Authenticated user special identity group has everybody that's authenticated to the system. And I can't add anybody to those groups. The operating system automatically adds people to that group. So here's some examples of built-in groups. Administrators has complete control over the system. Account operators can create accounts and reset passwords. Backup operators can back up the system. So you can go down that table and look. And if I wanted to make somebody able to create accounts, I can just drop them in an account operators group. User profiles. A profile is a collection of the user's settings for their computer. So their desktop wallpaper, their icons, all kinds of settings are going to be kept in a user profile. It keeps your settings separate from other people's settings. Typically on a Windows system, it's going to, when you log on for the first time, Windows is going to say it's getting the environment ready for you to use, and you're going to see a little hourglass or something. And what it's doing is it's making a folder that's going to hold all of your settings on the local hard drive. That's called a local profile. So your printers, your wallpaper, your settings for your spacing in Microsoft Word, whether you want like single space or double space, all of that is stored in your profile. It's all your personalized settings. The problem comes in is where users use different computers. Since it's saved on a local profile, a local hard drive, if I log into a different system, it's not going to have my wallpaper. It's not going to have all of that information. So an administrator can set up a special type of profile called a roaming profile that allows you to move between computers, and the profile is going to be stored on the server, not on the local computer. So no matter what computer I log into on the network, I'm going to have my wallpaper and my settings for Word and my bookmarks. That's called a roaming profile. So a user profile is stuck on one machine. A roaming profile is a profile that I put up and save to their home directory, and then I can move between computers and have the same settings. A mandatory profile is used, a special type of profile is used for like kiosk. Anything that you'd make changes to when you log on to that account is going to be thrown away when you log off. So if you have a corporate desktop that you want on all the computers where it has 4 icons and the corporate logo as a wallpaper, and you don't want anybody making changes, you can set up mandatory profiles, and every time the computer starts, it'll look the same. Sometimes uniformity is best. Here is the properties of the user profile. User and group accounts in Linux are used for the same purposes, for authentication and authorization. So they can prove who they are to the computer, and then you can tell them what they have access to. Linux also has a default user who has full control over the system. The account is named root, R-O-O-T. So in Windows it's called administrator, and Linux it's called root. Everything that you're going to do in Linux most of the time takes place in the command line. When you want to add a new user, you don't have a pretty dialog box. You go to the command prompt and you type user add, and then the name of the new user. After you do that, you have to create a password for them. It doesn't automatically create a password. You type password without the or in it, and then the user's name, and then you're going to reset the password for that user. Again, notice it's PASSWD. All right. All users must belong to at least one group in Linux. When you create a new user, a group with the same name is created. So if you create an account called Joe, you're going to have a group called Joe also. If I want to add the user to more groups, I use the group add command. So that would create the group add, and then use user add command to add the user to that group. So remember, in Linux you're going to be using a command line from almost everything. One reason we do that is because you can move between different distributions of Linux, and you can always drop down to the terminal and do your commands. You don't have to go fooling around trying to figure out where the user management tool is inside Linux. And it's also really fast. Fast for me to type the commands once I know them, and fast for me to get like maybe an Excel sheet from Human Resources, and I can add 1,000 accounts using these command line utilities within a minute or so. So I can do things really quickly in the command line. That's why a lot of people like using Linux. The problem with Linux is you got to learn all these command line utilities. Part of running a server, part of managing a server, is making sure we have enough space to store all the files that my users have. We also need to manage who has access to the storage space. And then we have to prevent users from storing things that they shouldn't. If you set up a server and allow users to store files there, eventually you're going to have users figuring out that they can store their home videos on the server or something else. And basically it's going to take up all the space on your server. You're not going to have any space for legitimate work files. So we need to be able to control that. A volume is part of the space on one or more disks that contains a file system. So a volume might be space on multiple disks. You'll be able to tell a volume because it has a drive letter in Windows. So you might have a drive letter called E, and that E drive might be space from multiple hard drives. It might be space from 4 different hard drives made to look like one big drive inside of Windows. In Linux, volumes are accessed as though they were a folder in the file system. The term partition is sometimes used interchangeably with volume, but they don't always describe the same thing. In Windows, a basic disk can be divided into 4 partitions. A primary partition can be formatted with a file system and assigned a drive letter. An extended partition is divided into 1 or more drives and can be formatted and assigned drive letters. So what we can do is, an extended partition, I can have some space on the drive, and I can have multiple volumes inside the extended partition. So I can have drive letters D, E, and F all in the extended partition. Primary partition is always have 1 drive letter. Only a primary partition can be the active partition, or the partition that you can boot from. So if I want to boot multiple operating systems, I have to have multiple primary partitions. The primary partition storing the bootloader or the boot files to get the computer started is referred to as a system partition. The partition with the operating system file is called the boot partition. So it's going to be the opposite of what you usually would think. So you boot from the system partition, and the operating system lives on the boot partition. A dynamic disk can be divided into one or more volumes, and the term partition is not used in this context. So the basic disk is the one we talked about before, where we can have 4 partitions on it. A dynamic disk, we don't use partitions. It's a new type of disk that Windows uses, and you put volumes on it. Inside the file system, we are going to have places that we use to keep track of the files on the system. And we have different types of table of contents, or tables that keep track of our files. One is called FAT16. One is called FAT32. FAT16 is usually referred to as FAT or FAT. It's been around since 1980, and almost every operating system supports it. FAT32 was released with Windows 95 in 1996. FAT16 is limited to 2 gigabyte partitions. So you can see these new hard drives that are out now that are 4 terabytes, 5 terabytes. You can't use FAT16 on those. FAT16, you would have to divide it up into 2 gigabyte partitions. So you would have 1 million drive letters if you wanted to do that. So it's an old technology, but we might use it still in when we use digital cameras and stuff like that, stuff of that kind. When FAT32 came out, it allowed partitions up to 2 terabytes. But they limit the volumes in there to 32 gigabytes because of the nature of the file system. So from FAT16 we had 2 gigabyte partitions, and FAT32 we can have 32 gigabyte partitions. So we typically don't use FAT32 either on our newer computers because our drives are just so big. Remember that FAT, or the FAT file system, does not support folder permissions. It also does not support encryption, compression like zip, disk quotas, or high availability or reliability features. So these are older file systems. Typically they're used exclusively in smaller devices like digital cameras or video cameras. You don't see too many places that have FAT anymore. Because of the limitations of the FAT file system, Microsoft came out with a new file system called NTFS. It was introduced in 1993. It came out and had all kinds of features that FAT did not. One of them is disk quotas. I can limit the amount of space a user can use on a drive. So I can divide up the entire drive between all my users. So if I have 10 users, I can say each user can use 2 gigabytes of space. So that solves my problem of somebody using more disk space than they should be able to use to do their job. I also introduced volume mount points. These allow us to mount a disk inside of an existing folder so that we don't have to assign in a drive letter. It's more Linux-like. We also to introduce shadow copies. It allows end users to restore older versions of files, kind of like the Google Drive that you have now, where you can go back and get previous versions. Before we had shadow copies, we would have to do a restore operation in the IT department to get a file back. Shadow copies allowed us to do a self-service model where a user could restore their own file from an older version. It also introduced file compression. It allows you to use zip compression on all the files on the file system so that you have more space. We also gain the encrypted file system. It makes the files inaccessible to everyone except the user who encrypted the file. So it scrambles it. So these features were not available in FAT. These are all part of the NTFS file system. Here's a dialog box that shows the quotas being enabled. So you have enable quota management. You can see they turned it on. There's a check mark next to it. It says deny disk space to users exceeding the quota limit. So in this setup, the users will get a warning when they start using more than 10 gigabytes of space. But it won't stop them from saving more files. It'll just nag them to get rid of some of their files. This is shadow copies. This allows me to set up a volume so that it makes copies of versions of files. You turn that on. File compression and encryption are a feature of the NTFS file system, and we check boxes to turn it on, turn it off. So this is the attributes dialog of a file. Notice at the bottom, compress or encrypt attributes. You can turn on compression or you can turn on encryption. You cannot use both at the same time. If you check one of the boxes, the other one will turn off. So if encrypt is checked and then I click compress, it'll uncheck encrypt and unencrypt the file. You cannot use both of those features at the same time. After I authenticate the user, I want to set up my authorization or who can access what. So there's two modes on a Windows system for accessing files. If I access the file from a remote location, so I'm on a computer on a network, but I'm getting the file from the hard drive of another computer, then that's called network access. Interactive access is I'm sitting at the keyboard on the computer where the file lives, called local. Share permissions are applied when the user attempts to access the file over the network. NTFS permissions always apply. Permissions are the authorization that we use in NTFS. Remember to use the principle of least privilege. Give users the least access necessary to do their job. You can assign permissions on files and folders. By default, when permissions are configured on a folder, they get those same permissions on all of the files and folders underneath. That's called inheritance. Here's an example of the NTFS file system permission system. So here's the group at top called everyone, and that group has full control, modify, read and execute, list folder contents, read and write to the folder called my data. As we click through the dialog box, we click different users, those permissions will change. Linux is a little more complicated when it comes to file systems. It has many different file systems that you can use. X3, X4, the Riser file system, and XFS are different file systems that you can use. By default, it's going to use X3 or X4. The reason why they have different file systems is you can use Linux to do many different things. If I want to have a high reliability file system, I might use the Riser file system because I think it includes journaling. So if the power goes out on the computer, it doesn't corrupt my files. So it's more dependable. So depending on what features you want, you pick one of these file systems. There are only 3 permissions in the Linux file system: read, write, and execute. And then there's only 3 different types of users that can be assigned those permissions: the owner of the file, the group that owns the file, and then everybody else on the system. So owner, group, or other. And they can be assigned the permission read, write, and execute. So here's a dialog box. Typically you would do it from command line, but this is a Linux GUI that allows you to change permissions. Notice the owner is me. I have read and write access to it. The group that the file belongs to is called live user. Has read and write execute permission. And then everybody else on the system has read only. When you want to share files over the wire, over the network, we use different protocols. The dominant file sharing protocol is SMB. That's the one that's used by Microsoft. You also call it Network Neighborhood. It is supported by Linux and Mac and Windows. Just because Windows is so prevalent, that allows us to send files back and forth. If I have a pure Linux shop, I'm probably going to use Network File System, or NFS. That is for Linux systems. It's just a different method for sharing files. When you access a file over the network, you're subject to both permission systems in Windows. You have share permissions and you have NTFS permissions. So when you access the file over the network, it's going to look at your NTFS permissions that we saw. It said full control, read, write, change, modify. Share permissions, there's only 3 of them: read, change, and full control. When you assign those permissions and you access the file over the network, it's going to combine the share permissions with the NTFS permissions, and you're going to get the most restrictive of all of those permissions. So for instance, if I have full control on the NTFS and I have read permissions on the share, then I'm going to have read permissions. It's going to be the most restrictive. So here's a picture of I'm setting the permissions on using the network access wizard. So I'm sharing a file or a folder, and then I can pull down and notice I only have a few permissions: read and write, or owner. That network access wizard kind of helps you to figure out what permissions to use. This is advanced sharing. This is the more less user-friendly of the 2 methods. The easier method being the network access wizard. The share permission, the advanced sharing dialog box gives you more options, but is also more complicated. Not everything's on one screen. Notice I have to click a permissions button to look at the permissions. This is the share management or computer management snap-in, and it allows me to look at which folders are shared. When I share a folder or file, that makes it available across the network. If a folder is not shared, that means I would have to log in at the keyboard at the system. I can also share printers in Windows in addition to files. When I share a printer on the network, I've got 4 different components that I have to set up in Windows to be able to access that printer. According to Microsoft terminology, the print device is the actual hardware where the print job comes out. The printer is the icon in the printers folder inside of Windows. The print server is the Windows computer that is holding the print job to be printed. And then the print queue is the storage where the print jobs are waiting to be processed. So we have those different components. We can put all of those components on one computer, or we can divide them out on different computers on the network. If I divide those jobs out, different computers on a different on the network, I have access control, so I can say who can print to a job. I can set up something called printer pooling that allows me to use multiple printers coming out of one print queue. Printer priority, that means that I can give certain users on my network higher priority for their print jobs. So for instance, if I'm in a law firm, the lawyers or the partners are going to get their print jobs faster than the clerks. So you can say this person's print job is more important than another. It'll come out the printer first when people are waiting. Print job management allows me to view everybody's print jobs in one place and be able to delete jobs or restart jobs. And then I can have availability control, so I can limit what days of the week and what hours the printer can be used. So when I use a shared printer and I have these different components of the shared printer on different devices on the network, I gain those benefits. Here's an example of a dialog box that is setting up printer sharing. Linux also supports Windows file sharing using SMB. So I load a piece of software or a package called Samba, and it allows me to access Windows printers and files. Once we set up the system, we need to monitor it to make sure that it is running at peak performance. We have some tools inside of Windows that allow us to monitor the operation of the server. One is called Task Manager. You probably used that before. I think you can hit Control Escape and get to the Task Manager. Task Manager lets you see everything that is running on the system right now. You can also stop programs. You can see how much utilization the processor is using, how much memory you're using. Event Viewers, a tool allows me to see what happened in the past. So Task Manager is used to see what's going on right now. Event Viewer lets me look in the past. I can see what happened last week, who installed what software last week. Performance Monitor allows me to set up custom tasks to monitor the system. I can set it up to schedule monitoring the system at 2 o'clock in the morning and then come by and watch it later. So it's the full-blown Performance Monitor tool that allows me to do advanced monitoring of the server. Remember, Event Viewer allows you to see what happened in the past. It categorizes the stuff that happens in the past in 4 different buckets. One is called information. Information is normal activity of the computer. You can ignore it. Warning provides information about events that should be brought to the administrator's attention. An error is generated when a process or service is unusable or a program crashes. Critical events are generated when the operating system experiences an error that causes the system to stop functioning. So typically errors will be for applications. Critical would be an operating system-wide error. Here's your picture of your event viewer. Notice the yellow icon as a warning. The red icon is an error. Performance Monitor is a collection of tools for pinpointing which resources are being overloaded. So you have monitoring tools, allows me to use those tools to look at what's going on now. Data collector sets, they have templates of data points called data collectors. And then you have reports where you set up the report to use the data collector sets. When you get into the Performance Monitor, you'll see objects called counters. It's a value representing one aspect of the object's performance. So an example of a counter would be a processor. So I could see the memory that's being used. It's important for you to, when you first set up the system, to create a baseline. If you're sitting in the IT department, somebody calls you on the phone and says the server's running slow, how would you know whether that's legitimate or just their imagination that the server's running slow. The answer is I have a baseline that I created when the server was running normally, and I can run a performance counter or a performance report, and then compare it to the baseline. Then I can see whether there actually is some degradation of performance in the server. So what I'd do is I'd create a data collector set, and I would start collecting data on the system for maybe 10 minutes. It's kind of like putting a dipstick in the car and figuring out what's the status of the oil in the car. When somebody calls and say there's a problem with the system, I can run a data collector set, the exact same one, for 10 minutes again, and then I can compare the two. Sometimes you'll have network performance issues with the server. Some things that can cause performance issues. It's 11 o'clock. Is poor or inadequate network design. So maybe I have too many workstations on the same segment. Poor network traffic management. So maybe things are being broadcast out. Maybe I have a giant broadcast domain where things are getting broadcasted out, so it's tying up all the lines. Bad wiring can cause network errors, so I have to keep retransmitting the same packet over and over and over. And then I can actually have attacks from people, denial of service attacks, where they flood my network with too much information. There are some tools I can use to monitor the network performance. One of them is called SNMP, and then the other one is called RMON. Typically you'll see SNMP. I see that more often than RMON. SNMP is a piece of software that runs on your device. It's called an agent. Inside of that agent, they have a management information base, which is a large catalog of all of the different aspects of the device that you can monitor. So what you do is you set up SNMP, you find out what you want to monitor in this management information base, and then you set up traps or thresholds to catch warnings. So I might look at my Cisco router. I look in the management information base, and I can see the processor of the router. So what I can say is, if the processor of the router it rises above 80% utilization, send me a message. That's an example of using SNMP. RMON is an advanced networking monitoring protocol that extends SNMP. There's two different versions. RMON 1 defines groups. RMON 2 can collect and analyze traffic at the network layer and higher. So RMON looks at data link and physical. RMON 2 can look at all the layers of the OSI model. Always remember to do backups of your system. Backups meaning that you're going to have a safety net in case things go wrong. A popular type of backup is an image backup, which copies the entire disk and can be restored without installing the OS. So I take a picture of the entire OS. It's a snapshot. I think Mac calls it a time capsule, and then I just drop that entire image onto the server. I don't have to reinstall the operating system. So we want to make sure that we do backups as part of our plan to maintain our server. If we don't, you may find one day that your server's not going to work because the disk fails. Remember, all disks fail. The average time for a disk, average lifetime for a disk is 5 years. So if you've had a disk for about 5 years, it's about to go bad. So you need to have backups. Windows comes with a utility called Windows Server Backup. You can schedule it to run. Your manual backups can be stored on network drives, fixed and removable disk volumes, and CD or DVD. It does not work with a tape. Tape is typically the storage of choice with operating system server backups now. If you want to use a tape, you need to use a different piece of software than Windows Backup. Like I said, the Windows Server Backup has limitations. You can go and buy utilities that are expensive, like Net Backup, Galaxy Backup and Recovery. It offers advanced disaster recovery solutions. Windows 7 has the Backup and Restore program. This is the Windows Backup and Restore program. So you can restore a one end system, one computer running Windows 7. We can also protect our data using fault tolerance. So fault tolerance is not backups. If you use fault tolerance, you still have to have backups. It's not a either or, it's both. So after you set up your backups, you can also set up fault tolerance. Usually with fault tolerance, we'll buy a special dedicated server, and the reason the server costs more is because we have redundant systems in the server. So we're going to have multiple power supplies, so that if one power supply goes bad, you don't have to shut down the server. Redundant disk systems, so I have multiple copies of the same files. And then I have multiple servers backing up other servers. That's clustering. An uninterruptible power supply, or UPS, is the device with a battery in case the power goes out. It protects the power against spikes, so it's a surge protector. It protects the power against sags, so that your server doesn't have a brownout or not have enough power. The main purpose of a UPS is to shut down the system correctly. It's not to keep the server running while the power's out. If we want to do something like that, we need a generator. The UPS is solely to make sure that the server is shut down correctly, all the files are closed, that type of thing. It's not to keep the server running indefinitely. Remember that UPS conditions your power, so it removes spikes and noise. It also is a surge protector. We can also use fault tolerance with disk systems. So we did fault tolerance with power, now we're going to have disk. And there's different ways I can set up my disk mirroring, or my disk system. I can set up a mirror. A disk mirror is, you have two disks, and every time you write a file to one disk, you write it to the other disk. Disk striping with parity is fault tolerance, and it makes it so that you can lose one of the drives in the RAID system, but it also gives you a performance boost. So disk striping is like mirroring with a performance boost. It's made for systems that need to be fast, high availability. Here's a picture of the RAID 5 system. Server clustering is made up of two or more servers. So in addition to having multiple power supplies, in addition to have multiple copies of the files, we make a whole nother copy of the server. That's called clustering. And I can set up my clustering two different ways. I can have a failover cluster in which one of the computers is not used at all, and then when one goes down, the other one turns on. That's failover clustering. So we don't use two servers at the same time. A load balancing cluster consists of two or more servers, and then all of the servers work at the same time to provide services. So it shares the load. That's the end of the chapter. More information about all of this stuff can be had by taking the courses NOS 130, NOS 230, NOS 120, and NOS 220. That's our server operating system classes. This is just a taste of the things that you would be doing on a server operating system. If you have any questions from this chapter, please email your instructor, and have a great week, and I'll see you next week.